Here we have an interesting test today. We got obvious test parts from a customer. Some of them are stainless steel, some of them are hot rolled, some of them are aluminum. On the 063 aluminum we have a little bit of damage. These parts are not PVC covered, and the stainless steel has a fine, very fine grain on the surface, and the customer says, what can you do not to touch that grain? Well, obviously, if you run it through a belt-driven machine, everything is going to be touched. But what we can do is we can run parallel to the grain, and then you can see what the results look like that. This will not give us as much equal distribution between the long edges and the cross edges, but it'll still do a satisfactory job in edge running. So I would suggest to run the machine in. We're going to start here with the 11 gauge hot roll. It has a very small dross at the bottom, which may require actually some belt sanding in order to remove that. We will see that in a minute. We have our standard blocks on the machine with a green belt. The more aggressive would have been the purple, and we may have to go to that. So all we do is we set the machine to the correct thickness, about 3 millimeters, and then we check, because this is how deep we can go into it. We check that we are just touching the conveyor belt. Now we are really on it. That here should be fine. So now we are about 3 millimeters below the surface, and that's what we will need for this material. So, all we do is we close the door, we turn the belts on, we turn the conveyor belt on, and we go really slow in the beginning, because again we have some dross on this part. If we can't remove the dross, we will move over to this machine, and we will just simply remove that dross with the belt sander first. Of course, once we use the belt sander, we're going to put a grain in the surface. So for the stainless, that's not an option. But it doesn't really matter, because the stainless actually was really clean cut. So if you can't cut that clean, it should be totally possible also to cut your hot roll clean, so that you wouldn't require the belt sander. So here we have some temperature in the part. That looks good. But as you can see, the edges are nice and round, well polished. But we still have some remainder of the dross in the corner on those parts. So, set that aside for a moment, and then we go to the 16 gauge. So, all we do here, we keep it 1.5. Now we are a little bit heavier in the belt. We keep the belt the same, and we take the time. So this is about 5 seconds now. 10 seconds. 15 seconds. 20 seconds. 20 seconds per part. Put plates on the machine. 1, 2, 3 parts up to side by side. This would make it about 9 parts per minute. Times 60, you would have 540 parts per hour. So I put that on here. Approximately 500 parts per hour. Yeah. And this was at 2 feet per minute. Oh, and you see the result? It's a very nice rounded edge at this speed. So this is actually the first side, and again here we have this, and the edge rounding machine is not designed to take that on. So that's the same 2 feet per minute. like this, if you can cut it clean, you get a good edge rounding result, so that the parts are painful around 2 to 3 feet per minute. And you get something that is a safe edge somewhere around 3 to 5 feet per minute. So again, we have very nice and good edges all the way around, but here where we have the dross, we just gotten round dross but not no dross. We have a little bit also on here. So we're gonna mark this. So this was 2 feet per minute, and we say cross belt only. Yeah, and what I will mark here for you is this, and yeah, that's basically that. And a little bit here. Okay. So much for the 60 gauge. We'll come back to this. So now we go to the stainless steel. Here we have our 18 gauge stainless steel. We don't need to do anything. The grain direction goes this way. So we are going this way. No dross. Very nice and clean. Then we go parallel squat at 2 feet per minute. What an edge rounding machine typically does with the surface, it actually makes the surface roughness come down. And in a normal grain that you would put on with 120 or 150 grit on a white belt machine, you are, like I say, you are going to reduce the surface roughness. These were very fine to start off. So here we have the result. Parallel to the brushes. And you see it makes a very nice finish still, right? I don't think that anybody can complain about this. So this was 2 feet per minute. Brass belt only. Need to write small so that you see more of the surface. These little scratches that you see were in there from transportation because the parts were transported without being individually wrapped. So we do the same thing back here where we have a little bit of a coarser grain, and this is again the burr side. And then the next part, we have 3 of them. We're going to go up always 1 foot per minute. So we're going to go from 2 feet per minute to 3 feet per minute to 4 feet per minute, or maybe actually we're going to go 1 foot down to 18 inches per minute. So this is the second side. I'm not going to write anything on there. And again, the parts per hour, the belt speed is the same and everything. These, you probably, if you run them like this, you can get more parts on because you can get 1, 2, 3 parts side by side, and they're overall shorter. So you would run about 600 parts per hour like this. And I think you will like those edges. So I'll write on here 600 parts per hour. There you go. So you need to keep those a little bit smaller apart so that they don't scratch. So here now, all we're going to do is we're going to go up to 3 feet a minute. At 3 feet a minute, we already said we have 3 side by side. So that's 5 seconds, 10 seconds. So that would be 6 parts per hour. And sideways, sorry, 6 parts behind each other per minute, 3 wide, is a total of 18 parts. Times 60 is almost 1,200. So this would be about 1,000 parts per hour. Always single side. 3 feet per minute. And of course, what you then see is the radius isn't quite as round. This is still nicely rounded edge. This looks like somebody pulled some PVC coating off here. Then we are going to do the last one at 4 feet. I'm going to take some of these, you know, they're old rags. The top here. So that we can sell some parts. And all the tiny scratches are from transporting it, the parts rattling against each other. Oh, and then the last one we're going to run at 4 feet a minute. 4 feet a minute, or that for stainless usually too fast. Stainless you want to run between 18 inches per minute and 36 inches per minute to get really good results. But maybe you are just looking for a minimum edge rate, and that would be that. So that is 4 feet per minute. And I will come up with how many parts per hour that is. Second. Over here, the short side. Wow. That's 5 seconds. That's under 8 seconds, 7 seconds, almost 10. So, bring this to 30. Which would be, in theory, 1,800 parts per hour. Let's say it is 1,500 parts per hour. I think you will like the surface. We're going to do the same thing, only we're going to start not at 2 feet a minute, we're going to start at 3 feet because the aluminum is softer and it will deburr better. And then the volumes are corresponding obviously to the stainless steel at 3 feet per minute. That doesn't make a difference, so it would be about the same 1,200 parts per hour. Extremely productive and very simple to set up. You see how quick we go between the different materials and the different speeds. So here's your aluminum. The aluminum does get a little bit dull in the machine from the surface, but the grain is very similar. So that's 3 feet per minute. This part had a little bit of damage from transportation resting on the other parts. You see the edge of another part basically being indented in here. And that doesn't matter. Since it's a brushing machine, it will still go over that raised edge. With a white belt sander, you would not want to do that. So in the meantime, while we are waiting here, I'm going to turn this on. And that's the back side of this. Get a little bit of a dross here on this edge too. So here we have a little bit more dross. So actually I'm going to go down to 2 feet a minute here, just for the dross side, and then we're going to do 4 feet on the other side. Of course, if you run a single part, it's a little bit like watching paint dry. It takes time for the part to come out. But I assure you, if you run volume, you will be super busy loading and unloading. So that's 2 feet per minute. And I did that because this was a draw side. We had a little bit of a draw side. Now these edges are really nice. And also it does a little bit more on the surface. And then on this side we're going to go to 4 feet. This. Especially when you run aluminum, you are your consumables are extremely low because it's a very soft material. So I'm going to run this as the draw side. I'm still going to run it at 4 feet a minute, then the other side of 5 feet, and then you see what that edge looks like. Like I say, consumables extremely low. Run things like 60 gauge, you're going to be a little bit in your conveyor belt, so that becomes a consumable, maybe $1.50, $2 per hour, and the block under $3 per hour. So that was 4 feet per minute. And then on the other side, you're going to run 5 feet per minute, and at that point, you're going to get over 2,000 parts. Side. You notice that I run all the parts in the middle, and you're welcome to do that on this machine. It doesn't matter because it melts from left to right, right to left. So they're always self-dressing. You don't wearing out the abrasive just in the center like on a belt set. So that's 5 feet per minute. That's what you can do with aluminum. Stainless, and again, so we're just going to go thicker here, the 3 again. I'm going to go a little bit heavier into the belt, I can afford that, and then we're going to go back to 2 feet a minute, and we are going nice and parallel to the belt, with a cross belt. Materials, your consumables will go up, maybe to $4 per hour or things like that, because you have more interaction with the edge, and especially then also the name is sharper and harder, so it uses a little bit more pressure. You can see the white edge already, that looks good, but here we also have some drops, which again, an edge rounding machine does not remove, but if you don't want to touch the grain, you are going to have to find cutting parameters where you are not creating any draws, just a sharp edge. Because the moment we put it on the belt sander, then you have a completely different grain in the first place. Then all bets are out, right? So that's the cross belt only, and then you have all the other edges where it didn't have a drop, really nice. And we do the same thing on the back. Then we have the aluminum that has quite a bit of drop, but I don't, on this material, I don't really see a grain. Yeah, no, there is a grain on this side, but I will show you what it is. That it helps when you run the parts diagonal from the back side. in how the rod then removed in the aluminum. So here on the stainless, same parameters as on the front, cross belt. And here, of course, this is the top side, great edges. So, now here we are on the 316. So all we do is we go up 4.5 millimeter. Good. Make the belt a little bit more. And then I will run on the burr side, I will run the part diagonally again. Nice and slow so that it can remove the rod. And I want to try to save this part in this shape. No, actually I'm going to save this also for the belt. Here we see huge white line, so a lot of radius because it was slow, and it takes the rod very nicely, makes a good rounded edge. See it from the aluminum on the thicker part, you can go more aggressive, you see all the debris on the conveyor belt. Super nice rounded edges. On this side, we're going to show you again a little bit of a grain. But this is the non-burr side, but we're going to go lighter by one turn, and we're going to go 3 feet a minute. Because if you don't have dross, you can go quicker. So, very heavy pressure in 3/16, diagonal, 2 feet a minute. So this is our direction, 2 feet per minute. And here we are running parallel, 3 feet per minute. And also on the cross belt. So, now we set up our belt standard, material thickness. We have a fairly quick belt because all we want to do is we just want to remove some of the dross. We don't want to go too much into the surface, not necessary here on the hot roll. And yeah, just hit it through. And we're going to go lengthwise, so if there is a grain, we make a nice straight grain. High friction belt holds the part very good. So you see that we grind this very lightly and we have that silver ring. A lot of the black surface is still on there, the mill scale surface, which is fine, that's what we want. And because it's a softer contact drum, we touch a little bit sharper on the edge. So, we're going to keep this for now here and then run this in a minute. And then we are going to do we have a second piece here that we're going to do the same thing. So, for that, we don't need to do anything on the top side. These little things here we can remove. And then we are going to now all we're going to do, we already have the set, we're going to go nice and slow, about 2 feet a minute. I'm going to turn this on, I'm going to turn this on. In the meantime, I will take the 16 gauge, and we are going to remove this rod that you see here. For that, we need to correct the surface thickness. We're going to try 1.4, see how that is. similar results. Okay. Meantime, here are our parts. So this is 3 feet per minute. And that was a wide belt plus a cross belt. And here, 3 feet per minute, wide belt plus a cross belt. You can of course get this combination in a single machine, but know this, that when you run through the white belt, it's always in the feed direction, the grain, where this makes the grain across it. So sometimes it's easier to run on 2 separate machines, rotate the part 90 degrees and run them with the grain. So now we can run the back side here. This was actually 2 feet a minute. I need to correct that on the other side. So this runs 2 feet a minute. And I'm going to run my last piece of 60 gauge. Here we have very little dross. We have a little bit here and here, and a little bit along the edges. Next I'm going to make this a little bit lighter. There we go. That's 3. That's all it took. Still, see, now we are so light that we just basically remove the edges of that. We'll see how that works. So here we are back. So this is 2 feet per minute, cross belt only, and of course this is the same thing. So that you do not, and here I said I wanted to correct this to 2. This is actually 2. Right. Going with that. So, and then we have the 16 gauge here. For that, we will back up a little bit with our belt. Aluminum, that we can really touch lightly here. So we go to 4.5. There we go. Aluminum on a white belt sander of course needs to be discussed because you remove a lot of material and that is combustible, and then if you have run steel with a spark, that's a problem. You would want 2 machines. Here's your aluminum part. You can see that we have a serrated edge here because the white belt sander does not do any edge. It just remove whatever is controlling it. So here we have the results. This was run lighter through the white belt, and you can still see that we have a little bit of this left. And this was run heavier, and it has a very nice edge. Everything is removed. Set up for this. We run the top side of this. That's 2 feet a minute. Then the aluminum we're going to run at about 4 feet a minute now that we have the dross removed. You still can see here on the side you have the side serration from that dross, but that's the edge round. then the opposite side, of course. Was white belt light. Not cross belt. White belt medium. Plus cross belt. So, now here goes the aluminum. All we're going to do is go in half. We're going to go again down. We're going to go heavier. And we're going to run at an angle. You see, there's some grain in here, but the better grain is really here. So first here, where the drop side is, we're going to go diagonal and we're going to go 15 minutes. Nice edge on the outside, also good edge on the inside. I think you will like that part. Nice, these are very paintable edges. And then here we have the grain. So we go down. And that then concludes our test strip. Really all we have. We're going to wrap those parts up for our customer, send them off to him, and have a phone call, I guess, next week to discuss the results. White belt plus cross belt at 2 feet per. At the end, all you have to do is you turn your machine off. It's always good to get the belts off the conveyor belt, so you want to bring them up a little bit, that they run freely. And that is all you need to do. You turn the main switch on, off, and you are done with the machine for the day, other than, of course, always the cleanup. Thank you very much.